I'm Michael Laine. I'm the president of LiftPort Group.
So what is LiftPort Group?
We're the guys working to develop the space elevator. We started out originally under NASA's Institute for Advanced Concepts as a research project. When we outgrew that, we created a company, LiftPort, and then we crashed in 2007. When the economy crashed, our funding got pulled, and we only just re-emerged just last year, but we're focused on a lunar elevator now instead of an Earth elevator.
And I understand you recently had a Kickstarter project. Can you elaborate more on that?
Sure. Yeah, we had a surprisingly successful Kickstarter campaign. That's actually why we were able to restart our company. We had asked just for $8,000, and 3,500 fans from around the world generated $110,000. So it was supposed to be a single experiment for a very specific task, to build a robot to climb up and down a string on a high altitude balloon. Became much bigger than that, and it allowed us to restart the company.
Just a robot that costs $8,000. I mean, in my view, that's pretty inexpensive.
It's funny. The last 5-6 years that we were out of business, the cost for electronics and communications have plummeted. So, whereas before we had to make these materials, make the equipment from scratch in a one-of situation, we actually could just get on the internet and order parts this time. It was a lot easier this time around. Our experiments will actually launch in May, June, and July this year. We'll go to 6,500 feet, the first one. The next one's 11,000 feet, and the final one will be 23,000 feet. That sounds kind of arbitrary, but that's actually the height of Mount McKinley. It's the tallest thing in North America, and we want to beat it.
And you mentioned that there's the robot that the Kickstarter funds are funding. Then the robot's climbing a tether, is it?
Yep.
Now, what is that tether made of?
For this particular experiment, it's a material called Vectran. We have 4.5 miles of it. I have some in my bag. Do you want to see it? Yeah, okay. Later. All right, yeah. So Vectran's an extraordinarily strong material. When we started working on the Earth elevator, we can't build that system yet. We don't have the materials for it. But for the lunar system, we do. There's about 6 or 7 materials that are strong enough. Things like Kevlar, Spectra, Dyneema, Xylon, Vectran. They're all in the right range. None of them are perfect, but they're all in the right strength range. And so with this experiment, it'll be Vectran.
So what is the difference between an Earth elevator and a lunar elevator?
So the Earth elevator has been in fiction. It's been a thought experiment for over 100 years. Imagine you have a ball and a string, spin it over your head. The string in the middle stays straight, right? Okay, so now expand that to an Earth-sized system. The Earth rotates, and you have a counterweight attached to a satellite deep out in space. The mechanics are the same. As the Earth spins, the string stays straight. So that's the Earth elevator. The mechanics for the lunar system are a little bit different. So you've got the Earth on one side, you've got the moon on the other. This has a lot more gravity. About here is something called the Lagrange point, where the gravity from the Earth and the moon balance each other out. So what we'll do is we'll take a rocket from the Earth, get to the Lagrange point, drop a string down to the Lagrange point, and pull that string back towards, not touching, but towards the Earth. Then the Earth's gravity actually pulls the whole system straight, and that's how you build an elevator on the moon.
Oh, that's very interesting, because it kind of reminds me of what's that movie Time Machine, where somehow the moon was shifted a bit out of orbit and a disaster happens. Now, with something like that, I know that was science fiction, that was a fantasy. Right. Is that possible for you guys to tether the moon and pull a little bit closer to Earth?
No, not even remotely, not a chance, no how, no way. The masses that we're talking about, initially the system on the moon will move about 40 to 60 kilograms versus the size of the moon, right? There's I don't even know what the mass of the moon is, but it's a lot bigger than that. Eventually, we'll build it up to a human-rated system so that 3 people can go to the moon every 3 weeks, and that's really our goal. And at that point, you're talking about 2,000, 2,500, 3,000 kilograms every 3 weeks. But that's still not enough to pull the moon out of orbit.
When you say you send the people to the moon, you mean you send them to this little tether?
Yeah.
They don't take the elevator straight to the moon rather than landing on the moon.
Exactly. We haven't compared to the Saturn V. The Saturn V rocket's the one that we took to the moon landings in the late 60s, early 70s. We don't actually have a rocket that big anywhere in the world, but there are 14 nations with 30 rockets that can get to low Earth orbit or geosynchronous orbit. Any one of those nations, any one of those rockets can launch to the Lagrange point. And if you can get to the Lagrange point, you can take our tether back and forth to the moon. So really what we're trying to do is make lunar development and lunar exploration and research available to the planet instead of just the United States.